Suppose we start with 3 points, and we draw two rays through those points in such a way that they share a common endpoint. The resulting shape is what we call an angle. Now, the two rays are the angle sides, and that common endpoint, A, in my example here, is what we call the angle's vertex. And there are several ways we can refer to an angle, all of which start with a little angle symbol. The first way is just to use the angle symbol followed by the vertex point. And the second way is to list the 3 points we have on the angle, but when you use that method, you have to put the vertex point in the middle. So BAC refers to this angle where, for example, ABC wouldn't. Now, sometimes when we're interested in the size of the angle, you'll see its degree measure written inside it near the vertex. In bigger situations, we may not have a choice in the notation that we use. In this case, for example, there are 3 angles that all could potentially be angle B. So in this case, we would have to refer to each angle using all 3 letters. Now, this can get a little tedious, right, when we have to refer to angles multiple times in an argument or an explanation. So a third notation puts a small number inside the angle and then puts that number after the angle symbol. Now, notice that there's no degree symbol here, which is how you can distinguish between a number that's used to refer to the angle, like I have in this example, versus a number that tells you the size of the angle, which is what we have over there in the first case. Angles can be sorted into 3 main categories based on their size. An angle whose measure is between 0 and 90 degrees, but not including 0 and 90 degrees, is what we call an acute angle. Now, an angle greater than 90 degrees but less than 180 degrees, again, not including those 2 endpoints, is called an obtuse angle. And an angle that's exactly 90 degrees is what we call a right angle. Sometimes you'll see textbooks include a 4th category, the so-called straight angle, whose measure is 180 degrees. But you'll also see textbooks that just call this a line rather than putting it in a special angle class. Now, in general, you should never make assumptions about anything in a geometry diagram. For example, just because an angle looks like a right angle, I wouldn't assume that it is unless I'm either explicitly told that in the description, or you can logically infer it from other information that you were given in the question. That's why I explicitly included the measure for the acute and obtuse angles. And you can tell that the middle angle is a right angle by that little box. That's a notation that's commonly used to indicate a right angle in diagrams. In the next lecture, we're going to continue this progression of building increasingly more complex shapes by looking at what relationships we can find or define when we have 2 or more angles rather than just one.